Hey there, everybody. We're here today. We're going to talk about mixtures and how to separate them. So, yesterday we learned what a mixture was. Go back a minute here. We learned that a mixture was something that could be physically separated. So, we're going to learn how to do that here today. And of course, it could be uniform composition, homogeneous, or heterogeneous, where it's not. So, here are just some ways that you might separate a mixture. The first way should sound familiar to you living here in Kentucky. Hopefully, you've heard of distillation before. So, all those distilleries are doing distillation. And what this does is it takes advantage of the different boiling points. So, I'll show some pictures here in a minute, but you have a mixture in the distilleries around here. They have alcohol and water mixtures, and those two things have different boiling points. So, alcohol has a lower boiling point than water does. So, we can we can heat it up where it evaporates off first. Then we can trap that gas in another container, and I'll show you that here in a second. Crystallization is going to be like if you dissolve salt in water, or you're out on the ocean and you have a bunch of seawater that you can't drink because it's salty. You want to try and get the water out of it, so you could boil off some of that water, and the salt would be left behind. Hopefully, you would have a way to contain that gas that you're boiling off, and of course, condense it to drink it. Then you've got chromatography. Chromatography is where you're going to separate a solution by allowing it to flow along a stationary substance. So you're going to try this at home with your coffee filters that we send home. That's going to be your stationary substance. We're going to use some ink. Hopefully, you have some black markers at home, and you're going to separate it by letting it flow along that piece of coffee filter. So we'll talk about there. Some of the pigments are going to move at different rates. So some are going to stay at the bottom and some are going to move up faster. Electrolysis is where you separate something by passing electricity through it. So if you pass electricity through water, you can separate the hydrogen and the oxygen, but that's not really it. That's more of separating a compound. All right, so here's an example of distillation. So this container has two liquids in it with two different boiling points. Let's say alcohol and water. So if I heat it up, the alcohol is going to turn to a gas first at the lower boiling point. And as it rises up here, it's going to come over into this little sidearm here. Now, this sidearm, you see the tubes going in? It has like a coil going through it where water goes in and out of the coil. And so it's providing this cold coil. So when the gas hits that cold coil, it condenses, turns back into a liquid, and you can contain that liquid over here. So the alcohol will come off, leaving the water behind. The more you do this in a distillery, the higher the percentage of alcohol is going to be. Is some water going to get over here too? Yeah, probably. But then you can distill it again. You could distill it a third time and make it more and more alcohol and less water. So, and crystallization, if you've ever seen rock candy, or maybe you made rock candy in some middle school, elementary school classroom, you take a lot of sugar and you dissolve it into water and hot water. And then when you put something in there, like say the stick here, to give the crystals a place to form, and as it cools down and evaporates even a little bit, you get that sugar crystallizing. We sometimes do a experiment with borax in here when we make Christmas ornaments as crystallization. We'll see when we get back into the classroom. Maybe we'll get to do that too. And then chromatography. So you're going to do an experiment like this, like I said, with the coffee filter. We'll have a procedure for you, but this is the basic premise of it. So let's say this is your coffee filter or a piece of it, and you put a sample right here. Now, as the sample moves up, so you put some water or some In your case, it'll be water. It might be some different solvents in the lab. But as it moves up through the paper, it's going to take that sample of whatever you put on there with it. But different things in the sample might move faster through the paper. So it'll separate them out. So what you should see with your black marker is that that black ink is made up of lots of different things, and as it moves up the paper, those different colors separate out. So that is the goal with the lab that you're going to do. And then there's electrolysis. So again, here now we're separating, in this case, a compound of water and running some electricity through it. Now what'll happen is you'll get, if this beaker's all full of water, you pass some electricity through it, you have the battery, the negative electrode here and the positive over here. What you'll see is the oxygen will start forming over here and the hydrogen will form over here. So you'll have a tube of hydrogen, a tube of oxygen, and you will have separated this compound into its two elements. So those are just some ways that you might separate things. All right. See you later.